to our revision video tutorial. I would like to go through what we covered in our first week and revise on the concept. So we started off with emphasizing differences between distance and displacement, and we said that distance is the total length covered between 2 points. The total length covered between 2 points. So it's a scalar quantity, meaning that it is magnitude only, whilst displacement is the straight line distance in a specific direction between an object and a specific point. The straight line distance in a specific direction between an object and a specific point. So displacement is a vector quantity. Why? Because it is both magnitude and direction. The SI unit for both distance and displacement is the meter, which is another reason why people tend to confuse these two. They have the same SI unit, which is the meter. We used this diagram to illustrate or emphasize the differences between distance and displacement. If you look at points P and Q, or object P and Q, you realize that the straight line distance from P to Q is 5 kilometers. However, if you go through path A, the distance is now 7 kilometers, and path B, the distance is 10 kilometers. So the 5 kilometer distance there, the straight line distance from P to Q, is our displacement, whilst the distance for path A is 7 kilometers and the distance for path B is 10 kilometers. The displacement, however, is equal in both cases, which is our 5 kilometers. So that was done to emphasize that displacement is equal in both cases, but distances are different. For path A you have 7 kilometers, for path B you have 10 kilometers, but displacement, the straight line distance between those 2 points in the specific direction P to Q, is 5 kilometers. Okay. We also emphasized the differences between speed and velocity, where we said speed is the rate of change of distance. Take note, rate of change of distance, and distance is a scalar quantity. So your formula for speed is equal to distance divided by time. And if you look there, your distance is a scalar quantity, your time is also a scalar quantity. Therefore speed is a scalar quantity. Speed doesn't care about direction. When you look at a car speedometer, it simply tells you the speed of the car. It doesn't tell you where the car is going. So speed is a scalar quantity. It does not have direction. Velocity, on the other hand, is the rate of change of displacement, and we saw that displacement has a specific direction. In our previous diagram, we said from P to Q, the displacement was 5 kilometers. So displacement has a specific direction. Remember, velocity is the rate of change of displacement, not the rate of change of distance. That makes velocity a vector quantity because it has displacement, which is also a vector quantity. And our formula is velocity is equal to displacement divided by time. Now these two are measured using the same SI unit. Another reason why people tend to confuse these terms. They are different, but they have the same SI unit, which is the meter per second. Meter per second. Okay, we saw that there are two cases here when an object is moving. Sometimes you have what is called uniform speed or constant speed, and sometimes you do not have constant speed. So when you have constant speed, you simply say your speed is equal to distance over time. But for non-uniform or non-constant speed, you need to determine what's called the average speed. So you break down your journey into sections of constant speed, and then you calculate these separately. So how do you do that? We looked at the formula. Average speed is equal to the total distance traveled divided by the total time taken. So that is for non-uniform speed. This is where your car, we can use the example of a car here. It moves at one speed from point A to B, and then it changes its speed between point B and C, and so forth. So that causes the total journey to have non-uniform speed, and we have to determine what's called average speed in such cases. So we looked at this example where George drives a car from town A to town B at an average speed of 80 kilometers an hour. It is known that the distance between the two towns is 180 kilometers, and in the next day George drives back from town B to town A at an average speed of 90 kilometers an hour. And in this case, you see that journey there from town A to B, he had a speed of 80 kilometers an hour, but when he was driving back, the speed was now 90 kilometers an hour. So this is non-uniform speed. This is non-uniform speed. So in order for us to calculate the average speed, we need to determine the speed in each of the two journeys. We also need to determine the time and add these up. So for time, we have to rearrange the first equation of speed there and make time the substitute formula that makes time is equal to distance over speed. So from town A to B, the distance between those towns is 180 kilometers, and in the first instance there, the speed was 80 kilometers an hour. So it took him 2.25 hours in the first case. We have to determine the time it took for him to travel from town B to town A. In the second instance there, from town B to A, George was now driving at 90 kilometers an hour. The distance is still the same, 180, so it took him 2 hours. Now for the average speed, here's what we do. We need to determine the total distance. We know that for the two towns, the distance between the two towns is 180, and he went from town A to B, that's 180 kilometers, and then traveled backwards from town B to A, that was another 180 kilometers. So 180 plus 180 divided by the total time. So we figured out that in the first journey it was 2.25, in the second journey it was 2 hours. So 2.25 plus 2, and when we simplify it, we get our 84.7 kilometers an hour. So this is how you determine your average speed. You have to break down your journey into sections of constant or uniform speed. So this is what we covered, and we also talked about acceleration, when we said acceleration is the rate of change of velocity. It is a vector quantity. Acceleration is going to be affected by direction. So you see that sometimes the acceleration is quoted as a positive number. For example, the acceleration due to gravity is 9.81 meters per square second. But sometimes you see your acceleration as a negative number, negative 9.81, for example. This means that acceleration takes into account the direction. So there's a positive direction and a negative direction. So when you see a negative acceleration, it's acting in an opposite direction to the velocity or the direction of the moving object. Acceleration is measured in meters per square second, and acceleration can be calculated using this formula: your change in velocity over time taken. So what does change in velocity mean? It simply means your final velocity minus your initial velocity. Your final velocity minus your initial velocity. Okay, so every time you hear this phrase change in, it simply means it's simply looking for the difference between two numbers. So there should be a final number and an initial number. You can also hear this with your temperature, your change in temperature, for example, simply your final minus your initial. So we can denote our final velocity there with a V and the initial with a U over your change in time or the time taken. Okay, there's another term which is called deceleration, which is used to describe an object moving at decreasing velocity. So when the speed is decreasing, when the velocity is decreasing, we say it's decelerating. For example, when you brake a car, it decelerates at 5 meters per square second, or you can say it accelerates at -5 meters per square second. So let's meet in the next video.